Hello children, I am here again with the third video of the same chapter, the language of chemistry. And in this video we will discuss about chemical equation. Okay, in last two videos we have learned till chemical formula. Okay, so we will start from chemical equation. It is a chemical equation. It is the symbolic representation of chemical reaction. Symbolic representation means we will use only symbols for the name of chemical compound or an element. Okay, we are not going to use the name, we will use only symbols. Let's take one example of burning of coal. Okay, how coal is burned? Coal is a form of carbon, you all know that. So we will use the symbol of carbon, that is C. Burning take place in the presence of oxygen. Okay, if no oxygen is there, so no combustion will take place. So carbon is burning means oxygen in the presence of air to give carbon dioxide. Now carbon dioxide is CO2. So this will be the symbolic representation of the chemical reaction. And what we are using? Symbols. Carbon is in the form of symbol oxygen and one molecule of carbon dioxide. Okay, so here we are using symbol. Now children, I think you all know that what are reactants and products. Reactants are written on the reactants are present on the left side of the reaction, and on the right side products are there. Okay, this one is reactant. This one means all the symbol present on left hand side. This is left hand side, and right hand side is product. Clear? These two, reactant and products, are separated by an arrow. Arrow means it is representing the reaction is proceeding towards reactant to product. Okay, it is reaction is proceeding from reactant to product side. Okay, this arrow represent, and this plus represent there are many reactants in this side, and each reactant is separated by plus. We will not use comma over here, we will use plus sign to separate the reactants. Clear? Let's take another example of sodium reacts with water. Okay, sodium symbol is sodium Na, reacts with water H2O to form sodium hydroxide, that is NaOH, and hydrogen gas is released. Hydrogen gas is H2. So this is the symbol used for the chemical reaction. So here sodium and water is present. So these are separated by plus sign. Okay, and this is called reactants. Reactants reacts to give a new substance which is called product, and the property of reactants and products are totally different. Okay, in a chemical reaction the properties of reactant is totally different from the product. Here new substance is forming, and reactants are losing their identity. That's why this is called a chemical reaction. Now children, see here, this reaction is called skeleton reaction. Skeleton reaction means what? Skeleton reaction means that the number of atoms on reactant side and product side is not equal. Okay, it is not equal. That means we have written the chemical formula as it is without balancing. Okay, so skeleton reaction is a chemical reaction in which balancing is not done. See, skeleton equation is a chemical equation that represent a chemical change but it is unbalanced. Okay, it is also representing a chemical equation, but here the number of atom in the reactant side is not equal to the number of atoms of product side. Okay, let's take one example of KNO3 gives KNO2 plus O2. Okay, this is one example. Now you can see here potassium 1, nitrogen 1, nitrogen 1. Oxygen is 3 over here, and this side it is 2 here and 2 here. That means 2 plus 2 is 4. So oxygen is not balanced. This means this is unbalanced chemical equation. That's why this is called skeleton equation, in which the equation is not balanced. Unbalanced chemical equation is called skeleton equation. Now we will move towards balanced chemical equation. See, balanced chemical equation, a chemical equation in which total number of atoms of each element, okay, of each element in reactants, that means left hand side, is same as the number of atoms in products, that means right hand side. That means potassium this side must be equal to this side, nitrogen this side must be equal to this side, oxygen this side must be equal to this side. If they all are equal in number, then you can say it is balanced chemical equation. Now children, we will learn how to do balancing unbalanced chemical equation. One more thing, why do you need to balance the atoms on left hand side and right hand side? Because according to the law of conservation of mass, it states that mass can neither be created nor be destroyed. That means whatever mass is before the reaction must be equal to the mass of product which is formed after reaction. Okay, that's why we do balancing, to follow the law of conservation of matter or mass. Okay, that's why we need balancing of an equation. Let's start from this only. It is unbalanced. Let's take one, let's write it again here. Then you will be able to understand easily what we are doing. Children, some points are there. You have to keep it in your mind while doing balancing, that we will do balancing of oxygen and hydrogen at last. Okay, you can take it in between also, but in some reaction it is better to keep hydrogen and oxygen at the bottom. Okay, and you can take other element above it and keep oxygen at the bottom, means last. Second last is hydrogen, and then you can take any element. Okay, it is your choice. Now see here what we can do. Potassium, this side is 1, this side is 1. Okay, it is balanced. Okay, nitrogen, this side is 1, this side is 1. Nitrogen also balanced. Oxygen, this side is 3 and this side is 4. So it is not balanced. It is not balanced. Potassium 1 both side balanced, nitrogen 1 both side balanced, oxygen 3 this side and this side is 4. So it is not balanced. So you have to do balancing for oxygen. So see, this side it is 3 and this side it is 4. So you have to take any number. This method is called hit and trial method. Okay, we are following hit and trial method. Hit and trial means you have to choose any number and you have to put it there where it is required, and then if it is balancing the number of atom, then it is fine. Otherwise choose any other number which will fit for the balancing. Okay, see, you have to write it like this, left hand side and right hand side. Potassium 1 atom, this side it is 1 atom. Nitrogen 1 atom, this side also 1. Oxygen 3 atom, this side it is 2 plus 2, 4. Okay, so we need balancing over here for oxygen. So take one common factor which can which can balance both equation. So let's take any number. Let's take 2 over here. Okay, so if we are putting 2 over here, then oxygen is 2 into 2 is 2 into 2 is 4. 2 into 2 is 4. Okay, you have to multiply the number of atom with coefficient. Okay, so 2 into 2 is 4, and now 2 is 6. Okay, now here it is 3. So what will be the number to make it 6? Obviously 2. It will be 6. So whatever number you are choosing, you have to put it here in the coefficient. Here I am putting 2 to make it 6. So 2 if I am taking, so 2 will be the coefficient for this full chemical formula. Okay, it is, you cannot put 2 in between the formula. You cannot put 2 here also. You have to put 2 as a coefficient of chemical formula. Okay, so now you can see 3 into 2 is 6 and 2 into 2 is 4 and plus 2, this side it is 6. That means oxygen is also now balanced. Now because of this 2, potassium is also getting multiplied. 1 into 2 is 2. This side also 1 into 2 is 2. So potassium also 2 both side. That means it is balanced. Nitrogen also 1 atom is here. 1 into 2 is 2. Again it is balanced. Over here also it is 2. So both side it is 2. Nitrogen 2, nitrogen 2. Oxygen 6, oxygen 6. Potassium 2, potassium 2. Now you can say that this equation is a balanced chemical equation. That is 2KNO3 gives 2KNO2 plus O2. This is a balanced chemical equation. Okay, it is clear. We will take one more example. Now see here, next example is Fe plus H2O gives Fe2O3 plus H2. Okay, this is your skeleton equation. Skeleton equation means it is not balanced. Now see how many atoms of iron is on left hand side. It is 1 this side and it is 2 this side. Hydrogen is 2 this side and here it is 2. So it is balanced. Oxygen it is 1 and this side it is 3. So you can easily find which one is balanced. This one is balanced. This one is not balanced and this one is not balanced. So what you will do for balancing? We will start from this element, that is iron. This is hit and trial method, children. You keep in your mind, you have to take any number, put it here or here and see it is matching or not. If it is not matching, then change the number. If it is here 1, here it is 2. So what we will do? We will put 2 over here because then only it will be 2 this side and this side. Now it is balanced. Hydrogen balanced. Now oxygen. This side it is 1, this side it is 3. So you have to balance oxygen. What you will do for balancing this? You will put 3 over here. See, if we are putting 3 as a coefficient, it will be 3 this side and this side. Both side 3. Now, if we are putting 3 over here, then hydrogen, you have to check for hydrogen again. So 3 into 2 is 6. 6 hydrogen this side and here it is only 2 hydrogen. To make it 6, what we will do? We will take 3. So 3 into 2 is 6. So put 3 over here. So 3 into 2 is 6 this side and 2 into 3 is 6 this side. Hydrogen is also balanced. Now iron is also 2 this side also 2. It is balanced. Oxygen 1 into 3 is 3 this side and 3 already this side. So it is balanced. So you can say that 2Fe plus 3H2O gives Fe2O3 plus 3H2O. Now you can say this equation is a balanced chemical equation. Okay, it is balanced. Now, clear? Now let's take one more example. Zinc Zn plus KOH gives K2ZnO2 potassium zincate plus H2. Now what you will do? You will write zinc, potassium, hydrogen, oxygen. Okay. Now put line left hand side and right hand side. Zinc here it is 1 only. So put 1 over here. Here it is also 1. So 1 over here. Potassium it is 1 over here. Put 1 here. And here it is 2. So put 2 here. Hydrogen it is 1 here. Hydrogen 1 and this side it is 2. Oxygen again 1 here and oxygen it is 2. So this equation is not balanced because this side all the elements are 1 atom only and this side it is 2 oxygen, 2 hydrogen, 2 potassium and 1 zinc. So zinc both side is balanced. Potassium here it is 1, here it is 2. What we will take to make it 2? We will multiply this by 2. Okay, so it will be 2 both side. Now what number we are using? 2. So this will be the coefficient. Okay, coefficient means it will come in the beginning of this formula. Okay, the coefficient will come first. Then you can see that potassium is 2 over here. Now hydrogen, this side it is 1, 1 into 2. Now 1 into 2 it will be 2. This side also 2. It is also balanced. Oxygen again 1 into 2 is 2 and this side oxygen 2. It is balanced. So see now one more time we will do recheck. So zinc is 1 atom this side also 1. Done. Potassium this side reactant is 2 and this side product is 2. Again it is balanced. Now next hydrogen this side is 1 into 2 is 2 and hydrogen it is already 2 atoms. So both side it is balanced. Now oxygen 1 into 2 is 2 and this side already 2. So it is also balanced. So like this children you have to use any number and whatever number you are choosing, like here I have chosen 2. So I am putting 2 as a coefficient. You cannot put in between the chemical formula. You cannot put 2 or any number in between the formula. You cannot put any number as a subscript. Okay, you cannot put it here also. You have to choose that number which is making other number of atom equal and that number you will put as a coefficient. Okay, now this equation is balanced chemical equation. Okay, this one is balanced. Now why balancing? What is the importance of balancing? Why it is done? Okay, why it is done? It gives exact number of atom or molecule which is taking part in the reaction and which is formed. See here, 1 atom of zinc reacts with 2 molecule of potassium hydroxide. Then this reaction will give 1 molecule of, nothing is written here, that means it is 1 molecule of potassium zincate and hydrogen gas is 1 molecule of hydrogen gas is formed. Okay, this gives us exact number of molecule or atom taking part in the reaction and the product formed, that is also exact number. Okay, before it was skeleton equation, you will not able to find the number of atoms or molecules taking part or it is not clear. Now after balancing, it is very clear that 1 atom of zinc reacts with 2 molecules of potassium hydroxide, gives 1 molecule of potassium zincate and 1 molecule of hydrogen gas. Okay, so that's why we do balancing. And second point is that because of law of conservation of mass, the number of atoms or the mass of reactant is equal to the mass of product. That means whatever mass is taking part in the reactant side, that mass of product will be formed. Suppose it is 10 kg of reactant, so here it will be 10 kg of product. There will be no loss or gain in the mass of the reaction. Next is how to make a chemical reaction more informative. Informative means it will give you more information. Like this, some symbols or some letters from alphabet we use to give some more information to a chemical reaction. You all know that small s represents solid state, small l represent liquid state, small g represent gaseous state. So if you are putting these symbols or letters, it will give you the state of the reactant or product. Okay, aq is used for aqueous solution. Dilute is used for dilute, or concentrated is used as concentrated. So these are the alphabets or some letters we use to represent, give some more information about reactant and product. Some symbol also we use like this. Arrow represent the reaction is proceeding towards forward. Forward reaction. This one represent backward reaction, and this arrow represent reversible reaction. Okay, so forward, backward, reversible reaction. And in some equation you will find that plus heat is that means heat is given out. It is exothermic reaction. Exothermic reaction in which heat minus heat is there, then it is endothermic reaction. Okay, so these are the information you can get from a chemical equation in which these symbols are there. Downward arrow represent precipitate. Okay, precipitate formed is represented by downward arrow. Upward arrow is gas evolved. Gas evolved is upwards arrow. So these are the information which is used to make chemical reaction more informative. Sometimes you can see that on arrow some element name or temperature or pressure is written here, or catalyst or promoter. These are written on the arrow. So these also give you the information that at particular temperature the reaction is taking place, at particular pressure, what catalyst is used, what promoter is used. These are the information you can get from any chemical reaction if these symbols and letters are used. Okay. Now children, I am giving you some assignment based on these balancing equation. You will do that assignment, and if you have any query you can ask. Okay, and it will take some time. That is quite common in all. So do practice of balancing. That's why you will be able to do it very quickly. Okay, one more method is there, partial method, which is not in your syllabus, but if you want I can tell you later on. This method is also used for balancing the equation. It is partial method. It is used for balancing the equation. Okay, balancing the equation. So this method we will do later on. It is not in your syllabus. That's why I have not discussed it here. Okay, you keep on practicing with hit and trial, so you will be able to do balancing little faster. Okay, take care children.